The following content has been provided by RWTH Aachen University.
Couple words on validity. And we're covering this here because we're just discussing this in the break here. A lot of classes will say, like, yeah, in statistics and running experiments is important, but you do this everywhere, so I'm not going to go into detail. That's why we are going into a little bit more detail here to give you a chance to hear about this. We are going to cover this more in current topics in HCI next semester. If you are thinking about doing a thesis in our area, then the current topics class is highly recommended. You'll learn a lot about how to actually set up, an experiment, how to ask the right research questions, how to get to results, and all these kinds of things. So we're going to touch this in some detail here, more on this, again, in current topics. So validity. There's a couple of things that we need. We need to find out, if you look at the way that you designed your experiment and your questions you're asking, are you actually asking questions that are that can you give you valid results? For example, are your variables defined in a way that they're concrete enough to actually be manipulated and or measured? So if somebody just says speed is my variable, that's still not precise enough. You need to be more concrete than that. For example, you have to say time since the cursor leaves the start until it reaches the target. Right? Then we're getting into really something that can be operated on. Internal validity and external validity are two things that come up quite a lot. Internal validity basically means, is the result that is the stuff that I found in itself logical, and how strong is the causal inference that I'm able to make? The causal inference means I've run an experiment and I've shown that menu type A is really faster than menu type B, and I've shown it, for example, to be a significant difference, quite a lot of difference in execution time. I've shown that the distribution of execution time, for example, are clearly separated between the two menu types, and I've shown this with enough users so that it's statistically very reliable. Wonderful, great result, but that's internal. It could be that my results are so wonderfully clean because the type of users I picked was very homogeneous, all undergraduate computer science students, and maybe there the effect is very clearly seen between these two conditions. If I now want to transfer this to the population at large, my external validity is not so great because I have done something with a very specific user population, very specific demographic, and I have to argue why this also would apply to the larger demographic of humankind at large. So oftentimes you get high internal validity in experimental studies, so like the ones that we've been talking about, more so than in for example, things that are just observative or descriptive or correlational. The external validity, on the other hand, can this result actually be applied to other settings, is often not so great when you do this in a lab. So, this lab study, not so great for the external validity because what we did there was not applied in an ecologically valid environment that actually resembles real life. So those two things often kind of contrast each other. You can get lots of internal validity by shutting out all the other disturbing factors, but you're measuring something fairly artificial, right? Or you could say, I'm going to let all these things happen. I'm going to run the study in the home of people and in homes of people at home and do all the kinds of things, have the natural noise of life in there, and then it's going to be externally very valid, but your results are not going to be as clear internally. And then finally, there's conclusion validity. Are the conclusions you are drawing from the data reasonable? So, for example, is it actually is the result significant enough to even say that there is a relationship between the variables? Not even claiming causality, but just the correlation between the two. So those are things to be concerned about when you design your experiment, whether what you're going to find in the end is actually going to be useful to the rest of the community. And it's also something that people who review your work will look at. Is this stuff internally valid? Is it externally valid? Is it useful for for other groups? Reliability means, can I replicate the experiment? And that's something that other disciplines do a lot, right? For example, in physics or something like this, it's perfectly normal that an experiment gets replicated by other teams just to make sure that it's really right. HCI isn't so good about this until now. It's been a discussion in the community. How can we be more, how can we make sure that our results get replicated more often? And in order to do that, you must report your experiment in a way that it can be replicated by others. So you describe clearly how your experiment was set up, what kind of computers were used, what kind of monitors were used, how big were they, what was the screen resolution, what was the age and education of your participants, what was the physical environment in which they were situated, were they in a room or were they running around with a mobile device in the street or in the park, whatever. So those are things that are important to make your study replicable. And then hopefully, if somebody else replicates your study, they get the same result, right? Otherwise, something interesting is going on. And this interesting could be some other influence that crept into your experiment. You might find something that you think is a great result, but in the end, after somebody else tries this out and finds, oh, we don't get the same results. What's going on here? You may discover that actually something else influenced your result that you weren't aware of at the time. So this could be all kinds of things. Of course, the random fluctuation of your data is something you cannot eliminate, right? If I have an experiment here and I measure average speed to tap a target with a cursor you control with your mouse, it's going to be different for every one of you. Obviously, that's random noise. That's not something you can eliminate. You don't want to eliminate. That's just how it is. But what we can do with random errors is just run more samples. If I just do it with you two guys, then I get 2 data points, and I don't know whether one is an outlier and the other one is the average or what's going on. If I run it with the entire room or with thousands of people, I get a nice, probably bell curve of results, and I can say a lot now about the distribution and the mean of that kind of speed with this mouse and this setup. So more people, more samples usually helps. Systematic errors are the ones that you want to avoid because they push the value that you measured into a direction that that is sort of biased and that is not something that you wanted to measure. So your instruments could be off. That's one thing that's very obvious. But your experimental procedure might not be properly counterbalanced, randomized. Your instructions might be biased. That's my favorite. When you tell the user, here are 2 different text editors I would like you to try. One is Microsoft Word, and the other one is this wonderful software that I spent the last 3 years of my life writing. And if it's not better than Word, then I'm not getting a degree. But I would like you to assess them very objectively and tell me what you think. Not going to work. So be careful about bias during the instructions you give. Participants, like I said, the recruitment process might filter participants unevenly. I'm always excited when people say, oh, we did a study, and 90% of people are using, I don't know, email or something, and they did the study in an online survey. Yeah, well, these people are all online, right? So, well, or I was done by asking all my Facebook friends. That's also selecting and not very evenly across the population. Experimenter bias, like I mentioned, this is sort of like what I just said about the text editor I spent my 3 years of my life on. And then the physical environment might favor one treatment over others. Maybe you're trying out a touch typing solution versus a keyboard that is labeled, a labeled and an unlabeled keyboard. But you're doing it in a space with really bad lighting, so even the labeled keyboard you can hardly read. Well, in that case, you're favoring the unlabeled keyboard.
This content was provided by RWTH Aachen University.